In this video, we are going to revise the metals, air and the water, and we would be using some past topical questions for our revision. But before we continue with our topic today, I want to appreciate those of you who have taken your time to subscribe to our channel. And for those of you who haven't subscribed to our channel, please like this video, share to other learners, and take some time to subscribe to my channel. Thank you very much for taking some time to subscribe to my channel. Let's get started. We will be starting with question number 1. In question number 1, this question is about cobalt and compounds of cobalt. The question reads, A. Describe how you could prepare a pure sample of crystals of hydrated cobalt-2 sulfate using dilute sulfuric acid and an excess of cobalt-2 carbonate. Now, you should be versed on how you can prepare pure samples given 2 different salts. How you can prepare pure samples of a particular salt given 2 different salts. Given a salt and a dilute acid. This is a dilute acid, sulfuric acid. Now you have been given a salt of cobalt-2 sulfate 2. And with excess of cobalt-2 carbonate. Here, you need, let me just brief you on how you can do this. Here, look at this diagram here. You have the salt, hydrated salt. You have the dilute acid. And you need to prepare a salt of what? You need to prepare a pure salt of what? Crystals of hydrated cobalt-2 sulfate. Remember that you have been given dilute acids. Remember that you have been given cobalt-2 carbonate. When you react sulfuric acid, sulfuric acid with cobalt-2 carbonate, what you are going to have when you dissolve cobalt-2 carbonate in dilute acid, that is dilute sulfuric acid, a salt of a sulfate salt is going to be formed, and that is the sulfate salt that they want us to prepare a pure sample of. So precisely using this diagram here, this diagram contains dilute acids. In this beaker here, we have dilute acids. So now, you now put in cobalt-2. You are now going to dissolve cobalt 2 carbonate in this dilute sulfuric acid. When you dissolve it here, remember that heating will facilitate or will speed up the substance to dissolve, will make it to dissolve faster. So when you dissolve cobalt 2 carbonate in dilute sulfuric acid, you heat it, and when you heat the mixture, Why are you heating the mixture? You are heating the mixture. One, is going to make the cobalt 2 carbonate to dissolve in the dilute acid. Two, is going to evaporate the water. So when you heat it, part of the water of the mixture in this solution is going to evaporate. So when you heat it until half of the water is evaporated, when half of the water is evaporated here, what happens? The solution becomes concentrated. We now go to the second step. The second step here will be what? It will be filtration. We will use the filter paper and a funnel to filter the concentrated solution that have been heated here. When we filter it, we will only have the filtrate. We will only have the filtrate. And this filtrate, remember that when cobalt 2 carbonate reacts with dilute acid, what is going to be formed? When cobalt 2 carbonate reacts with dilute acid, what is going to be formed is cobalt 2 sulfate. It's a sulfate salt that is going to be formed. So now the solution is now made up of cobalt 2 sulfate. Now this cobalt 2 sulfate now is filtered using the filter paper and the funnel. Now this is a solution, a concentrated solution of a cobalt 2 sulfate. The next thing is we are now going to do what? The next, crystallization. We are now going to evaporate the water, the remaining water in this concentrated solution, evaporate it to a point where crystals are formed. When we evaporate the water and we start filling crystals in the concentrated from the concentrated solution, the next thing we will do will be what? Wash and dry the crystals. When we not wash the crystals using deionized water or distilled water, we cannot dry it using what? We cannot dry it in a low oven, and pure crystals of cobalt 2 sulfate will be obtained. Let's write it down briefly. Once more, I advise you to put your in point form before describing anything, so that the examiner will know which stage at which you are, the stage at which you are. For instance, here, I said dissolve and heat the solution. Dissolve the cobalt 2 carbonate in dilute sulfuric acid and heat the mixture until half of the water is removed. That is, until it becomes concentrated. The next step will be filtration. Filter off excess cobalt 2 carbonate. When you filter off excess cobalt 2 carbonate, you are now left with a concentrated solution. Now, next step will be crystallization. Heat the saturated cobalt 2 sulfate solution to the point of crystallization. And the last point will be wash and dry the crystals. Wash crystals with little distilled or deionized water and dry in a low oven. And when you do that, pure crystals of hydrated cobalt 2 sulfate will be produced. The B part of it, once more, you can do it. Remember this diagram. The diagram will show you how you can go through it. Okay. Question B part of it. Complete the table. Complete the table to calculate the relative formula mass of anhydrous cobalt 2 sulfate. C small o S O4. Okay, use your periodic table to help you solve this problem. Now, if you look, cobalt is a transition metal or within the D block or a D block element. If you look at it, you are going to find cobalt. You are going to find cobalt. So now this is cobalt. Cobalt there. How many? Looking at the number of atoms here. How many atoms of cobalt are here? Okay, let me put it here. Let me use this. Okay, thank you. Okay, here, if you look at this diagram carefully, there's cobalt here. How many cobalt in this compound here? Cobalt, how many atoms are there? We have just one atom of cobalt. We write one there. Okay. Now come here, relative atomic mass of cobalt. If we look at our periodic table, the relative atomic mass of cobalt is 58.9. Then to have the total will be the number, the relative atomic mass times the number of atoms that are there. So it is 1 times 58.9. It will give us 58.9. Okay, now sulfur. Sulfur, they have solved it for us. There's one sulfur here. The relative atomic mass of sulfur is 32 from our periodic table. Then 1 times 32 is 32. Then oxygen. If you look at oxygen here we have how many atoms are there? There are 4 atoms. Now, if we look at the relative atomic mass, our periodic table, the relative atomic mass of oxygen in our periodic table is 16. To have the total mass of oxygen present there, it will be 4 times 16, which is 64. And now, if we sum up everything, that is 58.9, 58.9 plus 32 plus 64. We are going to have 154, 154.9. 154.9. Okay, now, let's go again to the C part. On the C part, complete the table to show the number of electrons, protons, and neutrons in the oxygen atom and cobalt ion. Okay, it should be noted here that sorry. Okay, if you want to do it here now, remember in our previous lessons, I told you that proton number plus the number of neutrons. The proton number plus the number of neutrons will give you what we call the nucleon number. Remember that the proton number, which is this one, is equal to the proton number, which is this one, is equal to the atomic number. And the atomic number is equal to the number of electrons. So let's proceed. So here, this is our proton number. Our proton number is equal to the atomic number, which is equal to the number of electrons. Therefore, what will now be the number of electrons? The number of electrons here will be what? There will be 8. Now, the number of neutrons. Now, I told you that since electrons is equal to the number of protons, so now the number of protons should be 8. Now, I told you that proton plus the neutron, proton number plus neutron number will give you our nucleon number. And this is our nucleon number. 17 is our nucleon number. So in order to have the number of neutrons, since neutron plus proton is equal to the nucleon number, which is 17, and we have the number of protons. So in order to have the number of neutrons, it will be 17 minus 8, which will be what? 9. Let's go to cobalt 2 ion. For the cobalt 2 ion, okay, 27 is the proton number, which is equal to the number of electrons, which is equal to the atomic number. 59 is the nucleon number. So now, since 27 is the proton number, this is the 27. Now, it is the proton number is equal to the number of electrons. The number of electrons are supposed to be 27, but the 2 plus charge shows that 2 electrons have been lost. Therefore, the number of electrons is from the 27. If 2 electrons have been lost from 27, then how many electrons are now left? The electron left in this ion here will be what? 27 minus 2, which will be 25. Okay, now we are told that proton number plus the neutron number will give us 59. We have the proton number to be 27 and the nucleon number to be 59. You have to have the number of neutrons, so it will be 59 minus 27. 59 minus 27. 32. Our answer will be 32. So the answer here will be 32. 32. Now, we have to proceed to the D part of it. The D part of it says a test for water. Anhydrous cobalt 2 chloride is used to test for water. Anhydrous, that is dry. Anhydrous cobalt 2 chloride is used to test for water. State the color change when water is added to anhydrous copper 2 chloride. Once more, before we come to our answer, for the purpose of revision, I want you to watch this. This is just a summary which I have made for you. Test for water. There are 2 tests for water. The first one is when we use anhydrous cobalt 2 chloride to test for water, and the second one is anhydrous copper 2 sulfate. So if water is added, if water is added to anhydrous cobalt 2 chloride, if water is added to anhydrous cobalt 2 chloride, what the color to show the presence of water? If water is to show the presence of water there, the color is going to change from what? The color change will be from blue to what? To pink. If it happens that the examiner gives you but anhydrous copper 2 sulfate, the color when water is added to anhydrous copper 2 sulfate, the color is going to change from white to what? To blue. So this is a tip for you, should in case you are given but anhydrous copper 2 sulfate. These are the color changes. Let's go back to our question. So, state the color change when water is added to anhydrous cobalt 2 chloride. Anhydrous cobalt 2 chloride, the color from what we have just seen, the color is going to be from blue to what? To pink. From blue to pink. That is just what we have noticed here. From blue to pink. Okay. 2 marks. Blue is 1 mark and pink is another 1 mark. So very, very important. E. An alloy of cobalt, chromium, and molybdenum is used to make cutlery for cutlasses. Okay, there are 3 elements involved in this alloy. There are 3 elements: cobalt, chromium, and molybdenum. Molybdenum. These are 3 elements that are involved. So now, the importance of this alloy is that the excuse me, the metal that resolve from it is not malleable. That is the metal that results from this, the particles or the atoms in it cannot slide over each other. It cannot be twisted. It cannot be hammered. It cannot change its shape when hammered. So now, the question is, which one of the following diagram best represent the structure of the alloy? Draw a circle around the correct answer. Draw a circle around the correct answer. If you look at it, there are three elements here. Of course, there is white, there is black, and there is that one here, this other one here. Okay, there are three here. But look at how the atoms are arranged. Look at how all the particles here are arranged. The particles, in the way the particles are arranged, shows that they can slide over each other. So this one, A, can change shape when hammered. It can change its shape when it is hammered. So in that case, A is not a good alloy of it, even though there are three particles involved there. B, look at B, there are only two particles involved. So B is totally out of question because there are only two particles. But we are told cobalt, chromium, and molybdenum. There are supposed to be three. So C, 1, 2, 3. There are three particles involved. But in C, see how the particles are well arranged. They are arranged in an ordered form. So they can slide over each other horizontally when hammered, and thereby changing their shape. So this is not a good alloy of it. So let's go to D. Of course, there are also three particles there. But the particles, the way they are being arranged, they are not in an orderly manner. They're not in an orderly manner. You will see that there is D. In between D, there is the structure is not in the right form. Look at it, the structure here is not in the right form. In between there is a black, white, there is all mixed up. But here you have, it is consistent. There is consistency. So D is the right answer. So we say D is the right answer for is best represented. D is best represented. In that case, we will circle D. D is best represented. Okay. 2. Which one of these substances is also used to make cutlery? Tick one box. If you look at it, one of the substances that is also used to make it is not mercury, is not sodium. Sodium is soft. It is soft. It can be cut with a knife. No, it cannot be. This one is liquid. It cannot be. Mercury is liquid. Sodium is very soft. Can be cut with a knife. So that one is outside. Graphite is also soft. It is not like that. Graphite is very soft. So we can't use graphite for in the making of cutlery. So the only one that is very good that we can see even in the market today that you can see that they are made of is the stainless steel. So the stainless steel is the one that is used for the making of cutlery. So this one is right. Stainless steel. Okay, let's go to question 2.1. 2.1, describe a chemical test which shows the presence of water. Okay, we are going back to the same question, similar question. A chemical test which shows the presence of water. Now, we have to describe the test now. We can now say addition of water. We can say addition of water to anhydrous copper 2 sulfate. Addition of water to anhydrous copper 2 sulfate, the color changes from white to blue. You can say, you can use this other one that we use here, the example that we use here, this example. You can also say addition of water to anhydrous cobalt 2 chloride. the color will change, but from blue to pink. So there are two answers you can give. You can give either you can give, since we have been asked to describe a test, it is not specific whether a hydrous copper 2 chloride or a hydrous copper 2 sulfate. So you can use copper 2 chloride or copper 2 sulfate, the hydrous. So now we have chosen to use but anhydrous copper 2 sulfate, which is white to blue. So you can, anyone is you are one you are versed with, you can use it. Addition of water to anhydrous copper 2 sulfate, the color changes from white to blue. You have 3 marks. The test alone is 1 mark, and the color change is 2 marks. So how could you show that a sample of water is pure? Remember, when we're doing a state of matter, remember that when water boils, when water has a sharp boiling point, and the sharp boiling point for pure water is 100. Water freezes at a sharp temperature, and that freezing temperature is 0 degrees Celsius. So when we can now say, when you are asked, how could you show that a sample of water is pure? When water boils at exactly 100 degrees Celsius, or when water freezes at exactly 0 degrees Celsius, it means that that water is pure. C. Describe how water is treated before it is supplied to homes and industry. Remember that the water we use in our cities today, in schools, in industries, in our homes, all that water is either taken from rainwater, it is either taken from seawater, it is taken from other reservoirs of rainwater, reservoirs from seawater. All those, they collect those collections. They come into a collection tank. When all the water with all the dirt, everything in it, they are being collected. In that collection chamber, water is now being treated. For instance, I want you to watch this. Watch this. So now, look at this one here. This is water that comes everywhere, be it rainwater, seawater, everywhere. It enters, before it enters into this chamber here, into this reservoir here, the water is being screened. The water is being screened. And pumped here into this place. Here, the first thing that is going to take place here is what we call filtration. Exactly here, there's what we call filtration. So untreated water from reservoirs, from rivers, from sea, goes into a water treatment plant. B, water is filtered through coarse gravel to remove large pieces of dirt, such as leaves, plastics, soil and other things. These, after passing a coarse gravel, the water is now filtered through a bed or a layer of fine gravel or sand. Either we use sand or sand, that is sand bed, or very small gravel to remove small particles. After all the small particles, soil, and other things have been finally removed, the water now settles. The water is now passed into what we call the chlorination tank. In the chlorination tank, what is added there is chlorine. There is addition of a small amount of chlorine. Chlorine is a disinfectant. It will help to kill some microorganisms bacteria, fungi, and other water microorganisms that were flowing in with water from the reservoir. Chlorine will disinfect them. Now, after the water has been disinfected, it is now passed before passing it to the general tank. It is also there is a certain amount of sodium hydroxide that is passed into it. After sodium hydroxide is passed into it, sulfur dioxide is also passed into it. The sodium hydroxide sodium hydroxide is added at this last stage here. After chlorination, sodium hydroxide is added at this last stage here to raise the pH. It helps to raise the pH of the water to a level that minimizes the corrosion. That is, it reduces the lead corrosion and minimizes lead level in drinking water. Then, before it is finally passed out, there is sulfur dioxide is also added. The sulfur dioxide that is added is used to dechlorinate. It helps to remove the chlorine that was used in the killing of microorganisms. It's used to dechlorinate before it is finally sent out. So, precisely using this sketch here to show how in a treatment of water supply sketch, we can use this to answer our question here. So the question now says that describe, there are just 2 marks, only 2 marks. You don't need to spend most of your time there, only 2 marks. Describe how water is treated before it is supplied to homes and industry. Just list it as I've said. You don't need to be describing because there's no space. The first thing is what? The impure water from a reservoir, in the reservoir, which has come from what? From rain, lakes, rivers, is treated by 1, there's filtration. That filtration carries many ways. The first filtration, it could be, during filtration, you can use sedimentation. You can use coarse, you can use, as we said here, sedimentation to remove large particles. You can use gravel or sandbed. Gravel and the sandbed are used to remove. Know that gravel, quartz or gravel, after quartz bed, you can use the sandbed. The sandbed is smaller particles, so the sandbed will help to remove the smaller particles or smaller debts that are present there. So after filtration and the sedimentation to remove the larger particles, it will now be followed by what? By sandbed to remove smaller particles. And after that, what is now followed? This is now followed by what? Chlorination. After chlorination, there's desalination. Desalination will only come in if we are taking water from sea, from salty sea. We will desaline it to remove the salty property in it. Then we can distill it to produce distilled water. So the major points there are filtration, sedimentation, gravel or sandbed. Then the next major point there is chlorination. Then you can add desalination and distillation. Those ones are if it is salty water. Okay, state 2 industrial uses of water. 2 industrial uses of water. It should be remembered that this water in an industry, water is used in industry for many uses. Here I've listed 3 for you. Here I've listed 4 for you to select. One of the uses of water in industry is water is used as a solvent. For instance, in companies that are using water for dilution or to dissolve some certain things, or you are making powder in chocolate company, you need to add some water, you need to add some sugar to dissolve the solute, you need to use some water. So we use it as a solvent. Then in heat industry, in industries or companies that are using heavy engines that they need to cool them, when they are too hot, we need to use water as a coolant to cool down the engine. Then when after everything, the debris, all the dirt in the industry, we need to use water for cleaning up. So water is used for cleaning. The fourth one, in industry that are producing maybe sulfuric acid, after in the production of sulfuric acid, so the sulfuric acid is finally diluted with water to form sulfuric acid, oleums. Yeah, diluted with oleum, which is diluted with, I think, sulfuric acid for that. We can also use it as a chemical reactant too. Beside the production of sulfuric acid, we can use it as a chemical reactant. Like in the case of hydration of ethane, when we want to make ethanol, we will react ethane plus water to have our ethanol. So there were just 2 marks there. You have a list of choices here to make. Okay, question number 2.2. Water is needed for industry and in the home. 1. Rainwater is collected in reservoirs. How is it treated before entering the water supply? Rainwater in some community or in some houses or in some estates, there's a collection of rainwater. Those rainwater now goes into a reservoir. It's from that reservoir that the water is being treated to supply those communities. How is this water treated? The first thing is that, as we did discuss in our previous question regarding the treatment when water is collected from reservoir, in the first step here is filtration. There is filtration or sedimentation, followed by sandbed. So all these are under what we call filtration. We filter all these, be it filtration, we have sedimentation. There is coarse sand to remove the bigger particles. Okay, now there's a sandbed to remove the smaller particles. All these are all under filtration. So filtration of the reservoir water, followed by chlorination to kill any microbes in it. That is 2 marks. Stage 2, industrial uses of water. We are still going back to what we discussed. Used as a solvent, used as a coolant, used for cleaning. Okay, stage 2, uses of water in homes. Of course, in your homes, water is the major thing that we use there. In our homes, we will use water for cooking. We will use water for cleaning ourselves and kitchen utensils and household utensils. We will also use water for drinking. B. In many regions, drinking water is obtained by distillation. In many regions, drinking water is obtained by distillation of seawater. Yeah, especially in areas in the desert region, within the Middle East. This is what you can find. There's distillation of seawater. So in many regions, drinking water is obtained by distillation of seawater. Explain how distillation separates the water from seawater. Distillation is another method of separation of 2 liquids. So this is how you can do it. And this is when the liquids, they have different boiling points. It is when they have a different boiling point. In the process of distillation, in the process of distillation, you will see that in the process of distillation, what will happen here? How the seawater, just 2 marks. So you just need to describe how water is collected. Use your knowledge of distillation, how you can separate water from seawater. So what I expect you to do is, you can write that using a distillation vessel. Using a distillation vessel, seawater is boiled. So you need to put seawater in a distillation flask. Seawater is boiled, and the steam enters. The steam now enters into the condenser, where it condenses as water. Then finally, the water now drips out and is collected as distilled water. So you should know the knowledge of distillation. Simple distillation. I am not talking of fractional distillation of petroleum in the petroleum industry. I'm talking of simple distillation. You will put your water using a distillation vessel. You put your water in it. You boil it. Remember that at a particular temperature, water will boil. When that water boils, water will do what? The seawater, when it boils, we are now transforming it from what? From the liquid seawater to what? To water vapor. That is as steam. So as seawater is boiling, it is now transformed into steam and enters into what? Into the condenser. In the condenser, it will condense as water and be dripping out into a collecting vessel as distilled water. It's 2 marks. Before we proceed to this other to question 2.3, there is a similar question here. The diagram shows stages in producing drinking water. In which tank is chlorine added to the water? In which of the tanks here is chlorine added to the water? We have the tanks here, reservoir. The reservoir is water that is coming from collected water that have been taken from different sources. Now it enters into tank A, which has sedimentation tank. It settles there in different level. Larger particles, smaller particles. Smaller particles are right down until the larger particles are right up in a segmented form. Then B is the filtration. There is filtration in B. Then in C, there is antibacterial treatment tank. That is where chlorine, that is antibacterial, that is where we add a detergent like chlorine to destroy the bacteria and other microbes. Then D is where the water now moves into a storage tank, where we can now supply it to homes, schools, industries, and other places, the main supply. Then they are telling us in which tank is chlorine added to the water. It should be tank C, because that is where the antibacterial treatment takes place. The antibacterial is a detergent, something that will destroy microorganisms, including bacteria, fungi, and other seawater organisms. So it is tank C. Tank C is our answer. Now, which method, the second one is, which method of purification would produce water most suitable for drinking? There are different methods of purification here. This is river, muddy river water. That is river that contain mud. Now, there are different methods of treatment. A, A treated it only by doing filtration, and they put it and they were used for drinking. B also treated it just by chlorination and was used for drinking. C, they did settlement, filtration. Of course, they did the settlement by removing, that is sedimentation and the filtration. They did the filtration and the sedimentation, removing all the various particles here, and it was used for drinking. D, they did the filtration. That is, they did the sedimentation. They did the filtration, the different methods of filtration, and right to the sunbed, and finally they chlorinated it. So if you look at these different methods, there is a problem here in method A, because you filtered everything, even though the water is now clean for drinking, but it is still harmful because you have not killed the microorganism. So method A is wrong. Method B, you have treated it by killing all the microorganisms, and you have sent the water for drinking. Yes, but it is not still appropriate, because you won't be drinking water with particles and all types of things running in it. You have not removed all the other particles, so it will not be convenient for you to drink. Same method B is wrong. Okay, method C, you remove only the filtration. The different method of filtration, the bigger particles and the smaller particles, but you have not treated it. You have not killed the microorganism. So C is also wrong. Then method D, you have filtered everything, remove all the big particles, the larger particles, leaves, larger sizes of rocks, then finally, and the smaller sizes of rock using bed sand. Then the water settles now, and the treatment tank now, you now use a detergent as chlorine to chlorinate it and kill the microorganism, and finally send for drinking. So D is the most appropriate, the most suitable method for treatment. So in that case, we will say D. Method D is the right one. Answer. Method D. So let's go back to question 2.3. Excuse me. The diagram below shows part of the water cycle. The water cycle here, what happens? This is the water in the sea. During the day, the sunlight produces a lot of heat. It now heats the water. There is water vapor. Water now is evaporated into the sky as steam or water vapor. In the sky as water vapor, which is in the form of gas, it now combines in the air at the higher altitude. Now, at higher altitude, the temperature is low. It is now being converted from the water vapor to liquid water. The liquid water now rains back to the surface as rain. Now, state the name of each of the following changes of state. A, from liquid water to gas. What is the change of state? The change of state in this process is what? From liquid water to gaseous water. What is the change of state? The change of state here is from A to this, we will call this from liquid water to gaseous. Here, the procedure, the change of state. It says state the name of each of the following changes of state. The name here, we need a name. The name used here is we can say evaporation. We can say evaporation. Here we can say evaporation. If you write evaporation, that is from liquid to gas, is evaporation. Evaporation. You could still say, if you don't say evaporation, you can say boiling. During boiling, water is converted to gas. Or you can say vaporization. Any of this is acceptable. Evaporation, boiling, or vaporization. On the other hand, from gas to liquid, what do we call that? When you have gas here, like what we here, from here, water vapor in the atmosphere now turns into liquid water and fall as rain. Now we are turning gas into liquid. What procedure is that called? The procedure here, from gas to liquid, we can call it condensation. We can call it condensation. We call it condensation. Condensation. Either you call it condensation or you can call it liquefaction. Liquefaction. Condensation or liquefaction. Excuse me. And the second part of it. The second part of it. Which one of the above changes of state is exothermic? Explain your choice. When you say which one of the above changes is exothermic, exothermic means energy has been lost. Energy has been lost. Exothermic means energy has been lost to the surrounding. Remember that gases, they have more energy than liquid. So for gases to be converted, to liquid, they must lose that energy. They must lose a lot of energy. Gases, they have more energy than liquid. So for them to be converted back, because we need more energy to convert liquid to the gaseous form. Now the gases now have more energy. For them to come back again to the liquid form, that energy must be lost. So now it should be from gas to liquid, because energy is being lost. And from gas to liquid, that is the one that involves condensation. So it is this one here. So it is from gas to liquid. So from gas to liquid, which is the condensation, that is the one that is exothermic. And the explanation, just I have said, is because energy is released in forming liquid water bonds, since gas has more energy than liquid. B. The B part of it says rain drains into rivers. Rain drains into rivers and then into reservoirs. Describe how water is treated before it enters the water supply. It is the same question we are repeating over and over. It is 2 marks. Describe how water is treated before it enters into water supply. As I said the other time, water is there's filtration. There's filtration. And the impure water is impure water 1. Impure water is filtered. This is filtered. Then, followed by what? Sedimentation. Filtered by sedimentation. We are talking of sedimentation. Sedimentation. Then, to what? Sunbed. This now is followed by what? Is filtered. That is sedimentation to sunbed, removing all the small particles. Yeah, just 2 marks, so you have to brief it. Then this is now followed by what? This is now followed by chlorination. Chlorination. This is now followed by chlorination. And then chlorination. Then finally, this is now followed by chlorination, and that's just all. Then supply. So impure water is filtered. Sedimentation now takes place. Then finally to sunbed, where the smallest particles are being removed. Now it enters into the chlorination tank. In that treatment tank, there is addition of chlorine that help to kill microorganisms. From there, it is finally sent out for homes. Okay, now the C part of it, explain how acid rain is formed. Acid rain, as I told you, acid rain is formed. Acid rain is formed from these gases that are produced in the atmosphere. Most of these greenhouse gases. So, and all these greenhouse gases, they are being formed. They are formed from combustion of fossil fuels. When fossil fuels, during the combustion of fossil fuels, what is produced? There are some of these greenhouse gases that are being produced, such as sulfur dioxide, carbon dioxide. Again, nitrogen in the air, either nitrogen from the air or nitrogen from car engines, will react with oxygen in the air at a very high temperature. They will react with oxygen in the air at a very high temperature. Or during thunder strike to form oxide of nitrogen. And when they form oxide of nitrogen, now the acid rains, there are now 3 oxides. There is sulfur dioxide, there's carbon dioxide, and there is oxides of nitrogen. So now, in this question, we have 4 marks there. You need to write detailedly. The first thing is, you need to show how the oxides are formed. 2, you need to show how these oxides will now react with the air or will not dissolve in water in the air to produce acid rain. So precisely, let's see how it goes here. Combustion of fossil fuels produce sulfur dioxide and carbon dioxide. Again, nitrogen in the air or in car engine react with oxygen at high temperature. At high temperatures to form what? To form oxides of nitrogen. Either it reacts with either at high temperature or it reacts during lightning. During lightning, because lightning will also produce high temperature to form oxides of nitrogen. So there are three oxides now: sulfur dioxide, carbon dioxide, and oxides of nitrogen. Now let's start with sulfur dioxide. The sulfur dioxide in the air dissolves in rain. That is in the air. It will dissolve in the rainwater in the air. To form what? To form what we call sulfurous acid. That is the sulfurous acid that we call the acid rain. The sulfurous acid, you find it here, is what we call the acid rain. When sulfur dioxide is mixed with water with rainwater. Then the other oxide is carbon dioxide. Carbon dioxide in the air reacts with water. The carbon dioxide in the air will react with water in the air to form what? Carbonic acid. It is this carbonic acid that falls as rain. That will also call it acid rain. Then the last oxide are oxides of nitrogen. Oxides of nitrogen will react with water in the air. The oxides of nitrogen in the air will react with the rainwater in the air to form what we call nitrous or the nitric acid that will fall down as acid rain. So there are three different types of acid rain. Sulfurous acid formed from sulfur and the rainwater in the air. Carbonic acid formed from carbon dioxide and the rainwater in the air. Nitrous or nitric acid formed from oxides of nitrogen reacting with reacting with rainwater in the air. So these three different types of oxide is how the acid rains are formed. So the number of marks will determine the nature of your answer. Now, fish lives in water, which is neutral, neither acidic nor alkaline. Acid rain decreases the pH of water, of course. Acid rain decreases the pH of water in lakes and rivers. Both of the bases, that is calcium hydroxide, calcium oxide, and calcium carbonate, can neutralize these acids and increase the pH. Explain why calcium carbonate is a better choice. They say both of the bases, calcium oxide and the calcium carbonate, can neutralize this acid in our lakes and the water and rivers. Can neutralize this acid and increase the pH. Explain why calcium carbonate is a better choice. Remember that when calcium carbonate with calcium hydroxide, calcium oxide, when calcium oxide reacts with water, when calcium oxide reacts with water, calcium oxide reacts with water. The calcium oxide here, when it reacts with water, what is going to be formed will be a calcium hydroxide, and that is going to be alkaline. And for that purpose, alkaline have high pH. So the water will be alkaline and not suitable for the fishes. But calcium carbonate, we say calcium carbonate is more preferred Because it is insoluble in water. It is insoluble in water. When it is insoluble in water, it raises the pH of water to what? To 7. It raises the pH of water to 7, making it neutral. It raises the pH of water to 7, making it neutral and more suitable for the environment for water to for fishes to live. Whereas calcium oxide react with calcium oxide. Calcium oxide will react with water to form calcium hydroxide, making the water to be alkaline. That is a pH above 7. So that is just a simple answer for that. Now, question number 2.4. Ozone is formed. Ozone is a form of oxygen. Ozone is present in the upper atmosphere and it prevents dangerous solar radiation from reaching the Earth's surface. Some of the chemicals that diffuse into the upper atmosphere decompose ozone. Chemicals that have this effect are methane, chloromethane, and an oxide of nitrogen. That is nitrogen 4 oxide or nitrogen dioxide. Which of these three chemicals diffuses? Which of these three chemicals diffuses the most slowly? Which of these chemicals diffuses the most slowly? Give a reason. Okay, looking at these chemicals here, methane has a molar mass of 16. Chloromethane has a molar mass of 51.5, and the nitrogen dioxide or nitrogen 4 oxide has a molar mass of 46. The one that has a higher mass, the highest mass is chloromethane with 51.5. So the one that is going to diffuse slowly, most slowly, the one that is going to diffuse most slowly is chloromethane. I say it is chloromethane. Why do I say it is chloromethane? Because it has the largest molecular weight. And remember, the larger the molecular weight of the particle, the slower the diffusion into the upper atmosphere. Question number 2. The second part of it. Chloromethane is formed when seaweed. Chloromethane is formed when seaweed decomposes. Name the compound in the environment from which seaweed might have obtained the following elements. Carbon. Yeah. Name the compounds in the environment from which seaweed might have obtained the following elements. Seaweed might have obtained carbon from carbon dioxide. Name the compound. Carbon dioxide or calcium carbonate. From carbon dioxide or calcium carbonate. Or calcium carbonate. Now, hydrogen. Name the compounds in the environment from which seaweed might have obtained the following elements. Hydrogen. Where do you think the seaweed might have obtained the hydrogen? They can only obtain hydrogen from water. From water. That is from water. Chlorine. Seaweed can only obtain chlorine from what? From sodium chloride. From sodium chloride. Sodium chloride. Sodium chloride. From sodium chloride, or what we call brine. or what we call sea water. Because seawater is another form of brine or it's another form of sodium chloride. Now, 3 reagents. How can chloromethane be made from methane? Chloromethane can be made from methane. The reagent here will be chlorine. Reagent is chlorine. Chlorine. Then the condition, they can only react that under UV light. When methane reacts with chlorine under ultraviolet light, under ultraviolet light, that's the UV light, there is continuous substitution of the hydrogen in the methane. So there is what we call, the condition is UV light, UV light or sunlight. You can say UV light or you can say sunlight. UV light, UV light, or at high temperature, or at high temperatures. At high temperatures. Excuse me. The 6th part of it, the oxide of oxygen are amphoteric. The oxides of nitrogen are amphoteric. Sorry, please. The oxides of nitrogen are atmospheric pollutants. The oxides of nitrogen are atmospheric pollutants. Describe how they are formed. Describe how oxides of nitrogen in the atmosphere are formed. Oxides of nitrogen are atmospheric pollutants. Describe how they are formed. From what we were doing when we just treated greenhouse gases, how oxides of nitrogen are formed, I told you that nitrogen in the air, or nitrogen from car engines will react with oxygen in the air at a high temperature or during lightning to form oxides of nitrogen. If you have done revision on your nitrogen circle, you will know what I am telling you. Nitrogen in the air or in car engines react with oxygen in the air at high temperatures or during lightning to form oxides of nitrogen. You write like that, you have your 2 marks. Then we have the 5th part of it, which is complete the equation for the decomposition of ozone. Ozone will decompose to produce oxygen. Will produce oxygen. And now, how do we balance it? We have 2 oxygen molecules here. We need to balance it here by putting a 3 here. Let me put a 3 here. Let me put a 3 here. Then let me put a 2 here. So we have 2O3. We have 2O3 to give 3O2. That's 2 marks. 2 marks. Okay, let's go to fractional distillation. Not fractional distillation. The extraction of iron using the blast furnace. So now the diagram shows a blast furnace. You see the diagram there with waste gases that are being sent out. Then material that are going in are what we call coke, that is carbon. The iron ore, which is iron 2 oxide. Iron 3 oxide, sorry. Then calcium carbonate. Then we have X that is sent from the bottom, and there is Y that is being released during the process. The following equation represent reactions which take place in the blast furnace: A, B, C, D, and E. Now, A is carbon plus oxygen to form carbon dioxide. B is calcium carbonate to give calcium oxide plus carbon dioxide. C is calcium oxide plus silicon dioxide to form calcium silicate. D is carbon dioxide plus carbon to form a carbon monoxide. E, we have the iron trioxide plus the carbon monoxide to give iron now plus carbon dioxide. The questions are now: 1. Which reaction is used to increase the temperature inside the blast furnace? If you have studied the blast furnace very well, what coke, that is carbon, will do when you put when the blast furnace is fed with coke, the iron ore, and the limestone. If you have studied it very well, the reaction that is going to be that one would be the reaction that is going to be that one will be what? Will be A. That will be A. So which reaction is used to increase the temperature inside the blast furnace? It is A. Reaction A. Is reaction A. Excuse me. B, 2. Which reaction is an example of thermal decomposition? Of course, thermal decomposition is there. Calcium carbonate is reaction B. Calcium carbonate into calcium oxide. That is reaction B. Three, in which reaction is carbon both oxidized and reduced? In which of the reaction, they are telling you which of the reaction is redox reaction taking place? Which of the reaction is reaction? From this, you see carbon here is reduced, now it is oxidized, so it is D, reaction D. So number 3 is D. Number 4, which equation shows the removal of an impurity from the ore? This is the removal of an impurity from the ore, where the silicate is formed. The calcium silicate is being formed, where the silicon dioxide is being used to remove where this one is being used to remove the impurity in it. So it is reaction C. 4 is C. 5. Reaction 5. Which equation shows the reaction of an acidic substance with a basic substance? Acidic substance and a basic substance. Acidic substance and a basic substance. Okay. Is D. Is reaction D. Why I say it is reaction D is because if you look at it, carbon dioxide is acidic. Carbon dioxide, this is an acidic gas. This is acidic. When it reacts with carbon, carbon is basic. Carbon is basic. When it reacts with carbon, it's going to produce carbon monoxide. It's going to produce carbon monoxide. And this is neutral. It is a neutral oxide. So this is like an acid-base reaction. This one is going to neutralize this to form this. So this is like an acid-base reaction. So that's why I say this reaction, carbon dioxide plus carbon, which is D, is that type of reaction, which shows the reaction of acid substance with basic substance. That is D. B. Use the diagram of the blast furnace to help you answer this question. What enters the blast furnace at X? What is entering at the blast furnace at X is what is entering at X is the hot air. It's hot air. It's hot air that is entering at blast furnace at X. Hot air. It's hot air. Hot air. What leaves the blast furnace at Y? Is the molten ion. What is going down is the molten ion. If you look at it here, this is the molten ion that is going out here, and this is hot air that is fed into the chamber. So it's molten ion that is going out. Molten ion. Molten ion. That is molten ion. Now, question number 3. Name 2 waste gases that leave the blast furnace. There are 2 waste gases that will leave the blast furnace. The 2 waste gases are, the first one is carbon dioxide. We can say carbon dioxide, which is the hot waste gas. The one is a hot waste gas. There is also carbon monoxide. And if you were to add 3, there is a nitrogen. Nitrogen there is also a waste gas. If you were to add 3, you have nitrogen. So should in case you are asked the third one, it is nitrogen. So we have carbon dioxide, which is the hot waste gas. That's the one that will be living here. These are these waste gases that are living from here. So the waste gases, they are hot waste gases. We have carbon dioxide, carbon monoxide, and nitrogen. Okay, C, the C part of it. The C part of it, 1. Describe using the malleability. The graph below shows the malleability of ion changes. Malleability of ion changes as the percentage of carbon in the ion changes. Malleability is plotted against increasing percentage of carbon. 1. Describe how the malleability of the ion changes as the percentage of carbon changes. You should see from the graph that the graph is sloped from left to right, indicating that as the percentage of carbon increases, the malleability of ion decreases. Or you can say as the percentage of carbon decreases, the malleability of ion increases. Just read it from the graph. Then 2, ion obtained from the blast furnace contain high level of carbon. Explain how the amount of carbon in the ion can be decreased. Now, in order to remove the amount of carbon in the ion, the first thing we are going to do is oxygen at high pressure is blown. Oxygen at high pressure is blown into the molten ion, causing oxidation of carbon to carbon dioxide that will escape. So it is very simple. You don't need to oxidize. You don't need to oxidize the carbon. Oxidation of carbon. Oxidation of carbon in the ion. So how do you oxidize the carbon? Oxidize the carbon in the ion to the carbon dioxide so that it cannot escape. You will blow. Oxygen at high pressure is blown onto the molten ion, causing oxidation of carbon to carbon dioxide that will escape as a gas into the atmosphere. Now, the last section of the question is on this is on aluminium. extraction of aluminum. It should be noted that aluminum is extracted from a bauxite, from the ore we call bauxite, and this is by electrolysis. It could have been by reduction, but it will be more expensive because it will require high energy amount of high amount of heat. So let's go to the question right away. Aluminum and iron are extracted from their ores by different methods. Aluminum is extracted from its purified oxide or by electrolysis. You can see the structure there, the cathode, the negative electrode, the anode, all these things like that. The molten oxide dissolves in molten cryolite. Aluminum is now there deposited. The question reads, what is the name of the ore of aluminum which consists mainly of aluminum oxide? That is bauxite. It is bauxite. The electrodes are both made of the same substance. Name the substance. It's graphite or carbon. C. Aluminum oxide is dissolved in molten cryolite before it is electrolyzed. It is dissolved in molten cryolite. Look at here. This is molten cryolite. Aluminum oxide dissolved in molten cryolite here before electrolysis. Okay. Is dissolved in molten cryolite before it is electrolyzed. Give two reasons why aluminum oxide dissolves in molten cryolite, why aluminum oxide dissolved in molten cryolite is electrolyzed rather than molten aluminum oxide alone. There are two reasons I have. The first reason is that cryolite is a better conductor of electricity. Cryolite is a better conductor, or you can say cryolite helps to improve the conductivity of the electrolyte. This is the electrolyte, this is the electrolyte here. So the cryolite will help to increase or will help to improve the conductivity of the electrolyte. Secondly, it helps, it is dissolved because it helps to reduce energy costs. When this is done, the temperature now goes down to 800 and 1000. They help to reduce the energy costs. D. Write the ionic equation for the reaction at the electrodes in the electrolysis. Remember that the aluminum oxides, the aluminum oxide, when dissolved, is going to produce the aluminum ion and the oxygen ion, as you see in this equation. This aluminum ion will be deposited at the cathode, the negative electrode. Oxygen will also be deposited at the anode, which is the positive electrode. Let's see how the reaction will occur. Write the ionic equation for the reaction at the electrodes in the electrolysis. Anode. At the anode, we will have oxygen. As I said, this is oxygen. We will have oxygen here. 2 minus. This is a gas. That will lead to what? There are 4 electrons here, so we need to put a 2 here. We need to put a 2 here. So these 2 times these 2 minus will give us 4 electrons. So there are 2, 2. So that is what is happening at the anode. That's what is happening at the anode. Then at the cathode, what is happening at the cathode? This is what is happening at the cathode. At the cathode, we have the aluminum ion. The aluminum ion plus is now going to undergo reduction plus to give, that is now deposited. At the cathode, that will be the equation. This is the equation to, that's what is happening there. Now that will be the equation at the cathode. The E part of it, ion is extracted from its oxide ore by reduction using carbon in the blast furnace. That is the diagram there. Place the element aluminum, carbon, and ion in order of reactivity with the least reactive element. From the reactivity series, you will know that ion is the least when these three are involved. Ion is more reactive, aluminum is more reactive than carbon, and carbon is more reactive than ion. Alternatively, you can put it in this form. You can say ion is greater than carbon, and carbon is greater than aluminum. Sorry, I've taken by the reverse, sorry. I say less than carbon, and carbon is less than aluminum. So you can say aluminum is greater than carbon, and carbon is greater than ion. You can put it in that form. Okay, use your answer to E1. Explain why ion is extracted by reduction using carbon, but aluminum is not. You should know that only reactive metals are extracted using electrolysis. So the simple answer for this question is that it is because carbon is more reactive than ion. Carbon is more reactive than ion, whereas aluminum is not. Aluminum is not, because aluminum is highly reactive and suitable only for electrolysis. Carbon is more reactive than ion, whereas aluminum is not, because aluminum is highly reactive and suitable only for electrolysis, which is less expensive. Okay, what is the name of the ore of iron, which consists mainly of iron 3 oxide? Iron 3 oxide that we use in the extraction of iron, the ore that we use in the extraction of iron 3 oxide is hematite. You can call it hematite. Then G, write balance equations for the reaction occurring in the blast furnace, which involve complete combustion of coke. We have just done that there. So complete combustion of coke is coke is carbon, that is coke and oxygen. It will be carbon, that is solid form, plus oxygen, which is a gas. It will give us carbon dioxide, which is a gas. The production of carbon monoxide from carbon monoxide from carbon dioxide. That is, so oxidation of carbon will be, that is, we did it up there. That is carbon dioxide plus carbon. Yeah. We said acid and a base to form a neutral oxide. So that is why we say to produce carbon dioxide, carbon monoxide. Still a gas. Then the reduction of iron 3 oxide. The reduction of iron 3 oxide will definitely be, that is Fe2O3, that is the solid, plus, for this to be reduced, we need to use carbon monoxide, which is a gas, to give iron, which is that is iron, where the iron is liquid, plus 3 carbon dioxide, which is a gas. Okay, this iron here, the iron here, that is the 3 carbon dioxide here. We need to put a 3 here. There is one here, so we need to put a 3 here. We need to put a 3 there. Yeah, we have iron. Let's say iron balance. Yeah. Yes, plus yeah. The other one is balance. Okay. The formation of slag, that is removal of the impurities. Impurity, which is the slag there that is being removed, and remember, slag is one of the impurities that is being removed, and it is used for the construction of roads. The black substance that is removed during in the oil company, that is used for the construction of roads. So we have calcium oxide, which is solid. It's always solid, plus silicon dioxide. Silicon dioxide is still a solid. When this meet is calcium silicate. Yeah, we have calcium SiO3, and that is liquid. So that is how it is formed. Calcium oxide plus the SiO2S, which is solid, to give us CaSiO3. So this is all you can do. So once more, I want to thank those of you who have subscribed to this channel. But if you haven't subscribed to my channel, please, once more, like this video, share to other learners, and most importantly, take your time and subscribe to my channel. Thank you for listening.